So atom economy simply looks at the mass of the reactants and the mass of the product. So the mass of the products here divided by the mass of the reactants. So don't forget you'll need to times it by the correct stoichiometric ratio. So it'll have to be a balanced equation that you use. And you don't include anything else. So reagents, catalysts, and byproducts are all ignored. And as you saw in the previous video, just because it has a good atom economy does not mean the reaction is safe. The byproducts might be dangerous. This particular one with high atom economy may have other issues such as disposable or how well products can be disposed of or how much energy it used up. So it's only one indicator of how green a reaction is. And so you're going to have to be able to compare reactions using the atom economy. And so I've just got one example of how to do one. And so this one here, determine the atom economy of the reaction to the left. This one's just 1:1:1, 1 molar. So that makes that easy on that side. But you keep on adding chemicals into the equations. And so the product here is 206. So you got 206 up here, and then you add you start with 1, 3, 4, and you add these three other molecules into it. And so that adds up to these numbers here. So always do formula substitute and units to make sure you get all the marks and the answer correct. And so that comes up to 77%. So you can compare that with another reaction to see whether their atom economy is better, and then consider a lot of other factors to see whether just having a better atom economy is a greener reaction. Okay, just a little bit extra too that may help you. You may want to do the E factor instead if you're doing an internal assessment. So the mass of the waste divided by the mass of the product. So that didn't take into account the waste, and so you might want to do that instead or do that one as well. So that's called the E factor.